Hello, everyone. I'm Poe Bronson, and I'm the Managing Director of IndieBio. And today on Founder Stories, where we spend time with the CEOs of the graduating startups from IndieBio, I have Alex Greenhalgh, the CEO and co-founder of Spintex. Alex, thanks for spending some time with me.
Hi, Poe. Thanks for having me on.
So, listen, you've got kind of a tricky situation because as your investor, I know your feedstock and how you're making alternative non-spider proteins. And I know who your big fashion house first customer is, who's doing development work with you. And I know the textile, performance textile validators that you have in the market. But you can't talk about these yet publicly. They're all kind of under these disclosure agreements that allow you, not in your public talk, not to talk about them. So I thought today we could just go ahead and show people. Do you want to take a shot at showing people what you're doing?
Yeah, absolutely. It all really starts with, as you say, with the feedstock. So I've got an example of some of our feedstock here.
Looks like water.
It will flow very much like a slightly thicker water. There's about 20 mils in here, and that 20 mils, when it's spun into a fiber, which I'll explain a little bit more how we do that in a second, but just from this 20 mils, we can make over 10 kilometers of fiber.
You can make 10 kilometers of fiber from 20 mils of your feedstock, your dope. Wow.
Exactly. And this is an example of the kind of fibers that we produce.
Beautiful. Look at that.
So you can see how they catch the light, the kind of silvery white color of them. And we use this feedstock, unlike in many other processes where you are essentially forcing a protein to become a fiber. You take a protein solution and use solvents that either evaporate very quickly or are very harsh to kind of push the proteins into bonding with each other. We actually rely on the feedstock's own intrinsic ability to form a fiber through a pulling force. So this is very much the kind of replication of what we see inside spiders, where they also have a liquid feedstock inside them that wants to become a fiber. It's waiting to be pulled, to have the orientation applied to the solution and for the bonds to start forming, and you produce this fiber through this self-assembly process. And it's exactly the same as what we do with our spinning machinery and our feedstocks. And this is a very unique capacity of our feedstock that we really haven't seen anywhere else.
So you're using the spinning technique of spiders, but not necessarily spider proteins. Alex, I think you said you'd spent 6 years at Oxford Silk Group. Is that correct?
Yeah, it's around 6 years off and on. I had a brief gap in between where I did some work in clinical trials. I've always had an interest in medical aspects of biology. But yeah, several long years at the Silk Group in Oxford, which was
investors are going to want to know who on your team has industry experience at this point.
So obviously myself and my co-founder Martin and also our co-founder Fritz Vollrath come from a long line of working in the kind of academic environment. Fritz is also a director of a few other biotech companies in the UK, but it's legitimate to say that there's a strong academic focus on our side. But we do have a broader advisory board, which also includes Chris Holland, who has an academic position in Sheffield, but also very strong ties with industry, has worked in numerous consortiums with industrial partners, and particularly Rob Harrison, who is our IP advisor. His background was actually at Gore, where he was working as the head of their IP development. But routinely now in his role as an IP attorney, he directly works particularly with SMEs and startups on developing their business development and their growth, particularly around intellectual property.
Let's talk about the performance of your fibers. I just in the last couple of weeks, Spintex, you guys did some advancements in your sort of feedstock methodology that arrived at yet more finer fibers. And my understanding is with every degree finer, you're seeing an improvement in toughness and performance. Where can you tell us a little bit about that, and tell us where you can take this over time?
Absolutely. When we look at spider silks, aside from their incredible strength and their incredible toughness, one of their key characteristics is how fine they are. Normally, a spider silk is starting at maybe 5 micrometers in diameter, and it only gets smaller from there. With some of the baby spiders, the spiderlings, producing fibers that are in diameters of hundreds of nanometers. So these are incredibly fine fibers. And when we compare this to, say, traditional silk, which we see in the textile industry, these fibers are normally at around 10 micrometers. So they're almost double the kind of largest spider silks. And as you say, interestingly, as we see in nearly all polymers, from metal fibers to glass fibers, as we reduce the diameter and we get finer fibers, we see this massive increase, particularly in tensile strength. And this may actually be one of the key attributes that makes spider silk so strong, its fineness. But that's only one part of the story, because as you say, there's toughness. And toughness is a kind of combination of the strength and the stretch of a material. And when you see that strength increase, but you also have really good stretch, which is what we see with spider silks and even traditional silks, you get this very high toughness. And our fibers have these stretch ability as well as this strength ability as well. So right now we can match traditional silks and textiles. So whatever silk you've seen in a scarf or in a shirt, we can match those properties. But because we have this control over the spinning process and can reduce the diameter of the fiber with aims to actually get to the fineness that we see with spider silks, we can see massive increases, particularly in toughness, where we have actually started to reach the point that we see in spider silks.
Alex, beyond the obvious booming apparel market for silks, what other markets can these performance characteristics unlock?
Absolutely. Obviously, textiles is a very logical first market for our fibers, directly coming in and augmenting the traditional silk market by reducing the environmental impact of the material. But beyond this, we're very interested in technical textile markets. So this can include textiles that are used in any kind of advanced engineering aspect. So this could be in composites, for example, or in high quality filters. But it also includes the medical textile market. So this could be things such as meshes or as components to go into a more complex medical device. We're very interested in both of these markets. We are actually part of the ground consortium that is going to be looking at the medical uses of our fibers. And we are also already talking with potential industrial partners to test and validate our materials for technical applications such as composites. And it really is that high performance characterization, particularly in the strength and the toughness. These are unique properties that can't readily be replicated with artificial polymers or metal polymers.
Alex, you've built one spinning machine, and I believe you are in the process of beginning to build 2 more. Tell us about the kind of CapEx needed or not needed to scale up your growth.
Yeah, I think this is a really key aspect of what we do. Instead of relying on very CapEx heavy processes to produce our feedstock and then having very complicated spinning machines that require many chemicals, solvents, many moving parts, we can really simplify the whole process, because fundamentally the real technology is occurring inside the feedstock. It's that ability to change from liquid to solid by physical force. That means that effectively all you have to do is pull from the feedstock to produce your fiber. And our spinning machines can be very simple in comparison to some of the spinning machines that may pop to mind from alternative protein spinners or even in the industry. So the CapEx requirements for the spinning machines are incredibly low, orders of magnitude lower than you would expect in the textile industry. And indeed, even our feedstock is very low cost, as we're using readily available consumables and a green chemistry approach to produce it, rather than relying on a bioreactor, which is a very heavy CapEx investment.
Alex, thanks for spending time with us today and sharing more with investors.
Absolutely. Thanks very much.